Alright guys, in section 4.2 we're going to talk about standard form of quadratics. So there's going to be three main forms of quadratics that we go over. Each of them kind of have their own key feature to focus on. In the last section we learned about vertex form. You could find the vertex there. In standard form, there's going to be different key features that you could notice as well. So to start out here, standard form of a quadratic equation is f of x equals ax squared plus bx plus c. Certain key features that I can find from this. My a value, similar to vertex form before, is just that a value in the equation. It's the coefficient with your x squared value. My axis of symmetry here, if I wanted to find this out algebraically, would be negative b over 2a. And finally, a unique key feature that I get from standard form is my y-intercept, so where that parabola crosses the y-axis. And that will be at my constant c value as 0, c. So if I'm looking for key features like a vertex or something in this graph, what's really going to be helpful here is using my calculator. So here I have the equation f of x equals 2x squared plus 8x minus 2. And I'm going to want to find the vertex, the axis of symmetry, my either max or min value, and then finally my range. Here I'm just going to focus on range because as you saw yesterday, your domain is always going to be negative to positive infinity. So what I'm going to want to do if I'm graphing this is I'll press y equals, I'll enter in my equation. Again, before you graph, make sure that you're in a good x and y axis. Again, I always do zoom standard. And when you graph, your parabola should appear. Now, if I want to find my vertex, you could kind of just click along through the arrows and trace. But if you're looking for a specific point, so here I'm specifically looking for my vertex. Something helpful on a TI-84 that you can do is press second, calculate, or that trace button again. And now it's going to take you to this menu. And here I could find a value, a 0, which is going to be helpful later on in this unit, a max, a min, or an intersection point. Looking back at this graph, I see that vertex is a low point, so that's going to be a minimum value. So I'm going to scroll down to minimum, press enter, and now my calculator is asking me to enter in a left bound. So you might already be familiar with this. Basically what you're doing from here is you're telling the calculator where to focus. So what I'm going to do is I'm going to scroll my left arrow till I get to the left of my vertex. Once I get pretty much to the left of it, you don't have to go too far over. I'll press enter, a line will come up, and now it's asking you to enter in a right bound. So similarly, I'm going to move my cursor to the right till I'm to the right of my vertex. Again, I'll press enter. For whatever reason, it asks you to guess. Just press enter again. And then it tells you that your minimum value is -2, -10. So that is my vertex, and from here, it's pretty easy to fill in the rest. My axis of symmetry is the x value of my vertex, so x equals -2. If I wanted to solve this algebraically, I could plug in negative b over 2a, so -8 over 2 times 2, which would in fact give me -2. I've already determined that this is a minimum. My minimum value would be -10. And finally, my range, my low point is -10. So I go -10, close bracket, all the way up to infinity, open bracket. The last thing that we're going to talk about in this video is shifting between vertex and standard form and vice versa. This is just a good algebra skill to practice. Depending on what we're working on, it might be easier to have a function in standard form or vertex form. So it's just a good practice to get into to easily be able to manipulate these equations to how you want them to look. So here, let's start by rewriting an equation in vertex form and moving it into standard form. Here I have the equation f of x equals -2 times x plus 1 squared minus 3. And I want to get it into standard form. So basically, what I want to do here is get rid of all the parentheses and combine like terms. So what I'll want to tackle first here is that x plus 1 squared. Anything squared is being multiplied by itself. So to expand this, I'm going to rewrite this as -2 times x plus 1 times x plus 1 minus 3. From here, to get rid of the parentheses, I'm going to multiply my first terms, x times x, outside terms, inner terms, and my last terms, which you may very well remember in Algebra 1 as foiling. So once I do that, I should get 4 terms here, negative 2 times x squared plus x plus 1 minus 3. Before I distribute that negative 2 out, I'll combine like terms in the parentheses. That x plus x will turn into a 2x. Now we'll distribute out that negative 2 to everything in the parentheses, and I'm left with negative 2x squared minus 4x minus 2 minus 3. And finally, my last step here would be to combine like terms. So my equation or function in standard form would be f of x equals negative 2x squared minus 4x minus 5. Now what's important to keep in mind here is that this is not a different equation. If you were to graph that original equation and that equation that I have in standard form, it should be the same exact graph. Again, I'm just changing how it looks. I'm not actually solving for anything or changing a value here. So at the end of the day, let's go from standard form to vertex form. Now it'll be really important to have your calculator, mainly because if I try to do this algebraically, I need to complete the square, and given that technology exists to do this for us, it's just kind of an unnecessary amount of work. So going from standard to vertex form, let's look at that past example that I just had. F of x equals 2x squared plus 8x minus 2. And here I already have all my key features. So I have vertex is negative 2, negative 10, and all that other stuff. If I want to write this equation in vertex form, I'll need my vertex, which I had found by graphing it. So all I'll do here is I'll plug this into my general form for vertex form. Now I have f of x equals a times x plus 2 squared minus 10. Last thing to plug in is my a value, which I get from my original equation. So my final equation in vertex form is f of x equals 2 times x plus 2 squared minus 10.